So friends, in this video we'll look at some of the dipole moment examples in chemistry for some of the molecules. So first molecule is beryllium chloride. So we have got beryllium and it makes two bonds with the chlorine, as you can see over here. So beryllium has got two electrons in the valence shell and it needs another two to make the stable configuration. So what it does is that it makes these bonds between with the chlorine, and chlorine has got seven valence electrons, it just needs one. So it makes this bond and then it gets that one extra electron after making the bond. So after the bond is formed, what happens is that since chlorine is more electronegative than beryllium, the dipole moment is created between them and it is shown like this. So this arrow should point to the more electronegative element. So chlorine is more electronegative, that's why arrow looks like this. And for the other part or other bond as well, there is this dipole moment that exists. So you can see that these two dipole factors are equal and in opposite direction. So they cancel out each other. So when they cancel out each other, mu is equal to 0. The net dipole moment is 0. And that's why it is called as non-polar molecule. So beryllium chloride is non-polar molecule because mu is 0. So even though the bonds are polar, you can see that there is this dipole moment in these bonds, individual bonds. The overall molecule is non-polar because these two dipole moment factors cancel out each other. Next example is CO2. So we have got this carbon atom in the middle. So carbon has four valence electrons, so it needs another four to complete the octet. So it makes this double bonds with the oxygen atom. So here what is happening is that the shape of the molecule is linear. Even though there is this lone pairs on the oxygen atom, the shape is linear, and that's why these dipole moment factors are also linear. So they are equal and opposite direction. That's why they cancel out each other, and that's why mu is equal to 0 in this case. So it is a non-polar molecule. The next example is SCO. So you can see here there is a carbon atom again, and at one end there is S and other end it is O. So here you can see that there is this dipole moment between carbon and oxygen in this direction, and then there is a dipole moment between carbon and sulfur in this direction. So even if they have the opposite direction, the magnitude is not same. Magnitude is not same. So in this particular CO2 example, magnitude was same and the directions were opposite. Here the directions are opposite but magnitude is not same. Why magnitude is not same? Because carbon is connected to the sulfur at one end and on the other end it is connected to the oxygen. That's why mu is not equal to 0 in this case. So this is a polar molecule. SCO is a polar molecule because mu is not equal to 0. Now let us look at this BF3 example. So in BF3, this is how the shape of the molecule looks like. At the center there is this boron and it makes these bonds with fluorine. Factors are shown like this, dipole moment factors. So basically these dipole moment factors cancel out each other and that's why mu is equal to 0. So this particular molecule is non-polar and it has got sp2 hybridization. The next one is SO2. So in the CO2 example, we saw that mu was 0 for the CO2, but in case of SO2, mu is not equal to 0. SO2, mu is not equal to 0. The reason being, even if the oxygen atoms are connected to the sulfur atom, since there is this lone pairs on the sulfur, the shape of this particular molecule is not linear. Shape is not linear. So shape is very important. when calculating net dipole moment. Shape is not linear. That means this dipole moment will be shown like this. Okay, from sulfur to oxygen. Oxygen is more electronegative than sulfur. Okay, that's why this dipole moments will be shown like this. And you can see that even though the magnitude is same, the direction is not opposite to each other, and that's why the resultant or net dipole moment could be shown like this one in downward direction. And that's why mu is not equal to 0, and since mu is not equal to 0, this particular molecule is polar. The last example, we have got CCl4, we have got carbon at the center, and then there are 4 Cl chlorine atoms connected to the carbon atom. So here as well, what happens is that these dipole moments cancel out each other. That's why mu is equal to 0, and when mu is equal to 0, this is called as non-polar molecule.